Hey look, it's pre-calculus again. So yesterday we talked about circles in standard form. Today we'll talk about circles in general form. General form is when it's all written out like this, before we've completed the square. When it's like this, you can't get the center and radius directly from there. So we usually put it in standard form. What we're going to do is we are going to take 3 points that we know are on the outside of the circle, use the general form to figure out these numbers, and then finally we can put it in standard form. And this is going to look really confusing, but what we're actually going to do is plug in the points, rewrite the equations so that we can represent it as the sum of 3 equations and 3 variables, which can then be solved using matrix equations. As you may remember, we did in chapter, I'm going to say 3, may not have been 3, but, and so if you have your calculator and batteries in your calculator, this will not be that challenging. If you don't, you can certainly do it by hand, but it'll take you longer. So to write the standard form of the equation of the circle, going through 1, -1, 5, 3, and -3, 3, you substitute each ordered pair into this equation. So x will appear in 2 places, y will appear in 2 places. So for the first equation, we're using 1, -1, and we substitute 1 here, and -1 here, and 1 here, and -1. We don't know what d or e or f are. We need to find those. And that's why we need 3 points, because to find 3 variables, you need 3 equations. Then we plug in 5 and 3 and 5 and 3. That's a plus sign. I just wrote it kind of small. And then -3 and 3 and -3 and 3. Kind of made a mistake there. So we have 1 squared plus -1 squared plus 1d minus 1e plus f equals 0, and so on. Now, before we can write this as before we can basically put this into the calculator as a matrix equation, we need to get, these are constants, these are just normal numbers. They don't have any variables in them anymore. So we need to move those to the other side of the equation. So 1 squared is 1, -1 squared is also 1. This adds up to 2, so we would subtract 2 from both sides to get that away from there. So that means this first line turns into 1d, just like here, plus -1e plus f equals -2, because we subtracted 2 from both sides. Here, we've got 5d and 3e and f, and this is 25, so we subtract 25 from both sides. That's 9, subtract 9 from both sides, so this becomes -34. And the last one, -3d plus 3e plus f equals, that would be 9, so subtract 9. That would be 9, so subtract 9. And this becomes -18. It's important to point out, whether these are positive or negative, if you square them, they always become positive. So you should never get a negative out of this part, with the result that these numbers should all be negative because you'd subtract them from both sides. Well, now we have a system of 3 equations and 3 variables, and we've learned how to do those with matrix equations in the calculator. You can also use elimination or substitution, and you're welcome to do that, but the probably quickest way is to use matrices. So what we're going to do is we're going to take the numbers, the coefficients, and put them in our matrix A. So we'll start with 1d plus -1e plus f. So 1, -1, and 1. The f coefficients are always going to be 1. And then in the next line, it's 5 and 3 and 1. And then -3 and 3 and 1. Times def, this is just the variables, equals, and on the other side, that's what this is for, -2, -34, and -18. Okay, I changed to a sheet of paper. So now you can go ahead and put this in the calculator. Remember, you go into your matrix by doing second and then the X inverse button. Go to Edit to enter your values. In A, make it a 3 by 3 and enter all the values. Then matrix again, Edit B, make it a 3 by 1 and enter in these values here. Then to solve the equation, you do A inverse B and hit enter, oops, enter. And you get D, E, and F. So D equals -2, E equals -6, F equals -6. We will actually check that this is right. Now we're not done. That's sort of the middle step. Now we've used the specific points to get D, E, and F, but now we're going to get rid of those. X and Y should really be variables. So now we can write the general form, x squared plus y squared plus -2x, that's dx, and then ey and f, plus -6y plus -6. And we're going to complete the square with this. We're going to put it in standard form, just like we did yesterday. So grouping the x's together, x squared, that's supposed to be minus 2x, and leaving the blank so I can complete the square. And then y squared minus 6y, and leaving the blank. And then this, I want to move this, so this will become equals +6. To complete the square, cut it in half, add the square to both sides. And then cut it in half, add the square to both sides. And 6 plus 1 plus 9 is 16. So our equation is x minus 1 squared plus y minus 3 squared equals 16. The center is 1, 3, and the radius is 4. To check it, we're going to go ahead and we're going to plug each of these points into our equation and see if they make it true. So, let's see. So our equation is x minus 1 squared. So we're going to start with 1, -1. So it'll be 1 minus 1 squared plus, and then y minus 3 squared, so -1 minus 3 squared, and it equals 16. So it works for the first point. Now we're going to put in 5, 3, 5 minus 1 squared plus 3 minus 3 squared equals 16, so it works for the second point. And finally, -3 minus 1 squared plus 3 minus 3 squared, and it's still 16, so it works for all 3 points. So just to review, take each point, substitute in for x and y in this general form, x squared plus y squared plus dx plus ey plus f. Then rewrite it as a system of 3 equations and 3 variables. Get the constants all on the right-hand side. Then you can write it as a system, as a matrix equation with the coefficients of d, e, and f, d, e, and f, d, e, and f in matrix A, and the constants in matrix B. Plug in A inverse B, and that gives you d, e, and f. Now you go back to your general form, substitute in d, e, and f, leave x and y as variables, and then rewrite in standard form by completing the square. Get your center and your radius.